Late November 1944, a rural crossroads near the German border. The rain had finally stopped, leaving a freezing mist hanging over the muddy fields and ripping through the fighting compartment. The American tank stopped instantly. A second later, heavy grey smoke began venting violently from its open hatches against a heavy German tank. Their vehicle was tactically outmatched. But the Sherman was not built to win isolated duels. It was built to be shipped by the tens of thousands, to drive across any standard bridge in Europe, and to operate for hundreds of miles without mechanically failing. To achieve this incredible scale, American industry completely rejected the bespoke, artisan engineering of the German factories. Instead, they relied on ruthless, uncompromising standardization. A transmission manufactured by Chrysler in Detroit had to drop flawlessly into a steel hull welded by Fisher Body in Michigan. There were no master machinists hand-filing gear teeth on the assembly line to make a stubborn part fit. Every single component was milled to strict, interchangeable tolerances. This philosophy of absolute uniformity extended to the smallest physical details. The tank's suspension did not use complex, overlapping wheels. It used simple, externally mounted bogies. They were easy to access, simple to clean, and did not trap mud that could freeze solid overnight. The engine compartment was designed with wide doors and ample clearance, recognizing that a cold, exhausted mechanic would eventually need to reach deep inside with heavy steel wrenches in the dark. Every tank rolled off the line with the exact same standardized toolkit packed inside. The German military command analyzed the Sherman strictly through the lens of their own doctrine. They measured its armor thickness, calculated its gun velocity, and concluded it was a weak, mass-produced target. The rest of the American column reacted immediately. They pivoted their turrets, seeking the muzzle flash, and returned fire. They believed that destroying enough of them would simply grind the American war effort to a halt. What they failed to understand was that they were not just fighting a tank, they were fighting an unbroken industrial blueprint. To the German gunner sitting in his pristine, silent, heavy tank, a burning Sherman in his optic was a definitive victory. He believed that once the armor was pierced and the engine stopped, the machine was permanently erased from the war. He did not know that his lethal, specialized weapon was about to clash with an entirely different kind of machinery. If the tanks were intentionally designed to be expendable and tactically inferior, how does an army turn a weaker vehicle into an operational juggernaut? Night had fallen over the American rear echelons. Inside a muddy clearing hidden beneath heavy pine branches, the roar of a massive radial engine cut through the freezing rain. An armored recovery vehicle, essentially a tank chassis fitted with heavy winches and a pivoting steel crane, was dragging a casualty backward through the mud. It was one of the Shermans knocked out at the crossroads. To the German gunner who had pulled the trigger hours earlier, this machine was a confirmed kill. The armor had been breached, the engine was dead. But in the American logistical system, a tank was not destroyed until it had completely burned to ashes or its structural hull had cracked in half. Everything else was merely a mechanical problem waiting to be solved. A volley of armor-piercing shells crossed the distance. 2 projectiles struck the glacis plate of the Tiger. The recovery crew dropped the heavy steel towing cables. Almost immediately, a swarm of mechanics from an ordnance maintenance battalion climbed over the cold steel. They carried heavy wrenches, blowtorches, and canvas tool bags. There was no hesitation. They did not need to consult complex factory diagrams to understand the machine, because every Sherman in the theater was built with the same fundamental DNA. The lead mechanic inspected the jagged hole punched straight through the front transmission housing. In a German heavy tank, replacing a shattered internal drive system often required lifting the entire armored turret off the hull with specialized gantry cranes. It was a delicate, agonizing process. The American crew simply attached their crane to the front of the Sherman, unbolted the massive steel housing, and pulled the entire transmission assembly out in one single piece. This was the shadow machinery of the American war effort. The Army had pushed its assembly lines all the way to the edge of the battlefield. The mechanics dragged a wooden crate from the back of a supply truck. Inside was a brand new transmission unit, built thousands of miles away in Michigan, sealed in heavy grease. Because the tolerances were strictly standardized, there was no need to hand-file the gears. The new unit was hoisted up, aligned perfectly with the hull, and bolted into place. Nearby, a welder ignited an acetylene torch. He cut away the jagged edges of the German shell hole, grabbed a square plate of standardized steel. Inside, the German crew heard a sharp, deafening ring that reverberated through the hull. But the tank did not shake, and welded it directly over the wound. Sparks cascaded over the wet armor. Inside the fighting compartment, another crew was performing a darker task. They were hosing out the interior, scrubbing away the violent aftermath of the previous day, and replacing the ruined radios. It was grim, relentless labor, but it was incredibly fast. By dawn, the engine coughed, sputtered, and roared to life. The tank reversed out of the clearing under its own power. A fresh crew climbed through the hatches. This was the invisible system the German commanders could not see. Their doctrine counted destroyed tanks. The American doctrine counted operational readiness. The American forces could sustain heavy tactical losses during the day, recover the disabled vehicles at night, and push them back into the line the next morning. It was a continuous cycle of recovery. But repairing a broken machine did not change its physical limitations. A patched Sherman still had thin armor. It still carried a gun that shattered harmlessly against the thick plates of a heavy adversary. The mechanics could keep the tracks moving, but they could not rewrite the laws of physics. If the Americans could replace their losses and keep moving, how did they actually defeat the massive enemy armor they still could not easily penetrate? The Sherman commander peered through his periscope at the ruined edge of a French village, 200 yards down the cobblestone street. The interior did not spoil. The American 75mm rounds had shattered harmlessly against 150 millimeters of steeply sloped Krupp steel. The massive silhouette of a German heavy tank sat idling, its long 88mm gun covering the intersection. The American commander knew his standard 75mm gun could not penetrate that thick frontal steel, but he did not order his gunner to try. Instead, he ordered a single white phosphorus shell loaded into the breech. The gun fired, and the shell exploded in a blinding cloud of thick white smoke directly in front of the German tank. The superior Zeiss optics were instantly rendered useless. Then, the American commander reached for his most lethal weapon, the black plastic microphone of his radio. In the German doctrine, the heavy tank was an apex predator, designed to hunt and destroy on its own physical merits. In the American doctrine, the Sherman was a node in a sprawling, interconnected web. It was not meant to fight the heavyweight alone. It was meant to find it, blind it, and hold it in place while the rest of the network arrived. 10 miles behind the American lines, a battery of 155mm howitzers received the radio transmission. Sweating artillerymen shoved 95-pound, high-explosive shells into the breaches. Within 3 minutes of the American tank commander's call, the sky above the French village tore open. The Tiger's loader hauled another heavy brass casing from the ready rack and shoved it into the breach. The massive metal block snapped shut. The artillery barrage did not pierce the heavy Krupp steel of the German tank. It did not have to. The concussive shockwaves of the heavy shells detonating in the street achieved a different kind of destruction. The blasts sheared off the tank's radio antennas, severing its connection to command. The flying shrapnel shattered the external glass prisms of the commander's cupola, sealing the crew inside a blind iron box. The explosions violently stripped away the squad of German infantry assigned to protect the tank's vulnerable flanks, and as the cobblestones cratered, the delicate, highly tensioned tracks snapped. The pristine fortress was now deaf, blind, and permanently paralyzed. With the heavy tank pinned down, the second layer of the American network arrived. The radio call had also summoned a dedicated tank destroyer platoon from the reserve. A pair of lightly armored M36 Jacksons, carrying long, high-velocity 90mm guns, crept through the shattered side streets. They did not attack the thick frontal plate. They maneuvered into the alleyways, found the much thinner, flat steel of the German tank's side armor, and fired. This was how the American military systematically dismantled the German heavyweights. They did not fight tank against tank. They fought an integrated radio network against isolated steel boxes. Every American Sherman was equipped with a two-way radio, allowing fluid communication. The gunner smoothly adjusted his elevation wheel, selected a second Sherman desperately trying to reverse into a shallow ditch, and fired again, between armor, infantry, artillery, and air support. They possessed the logistical wealth to blanket a grid coordinate in high explosives simply to neutralize a single stubborn vehicle. The German crew, trapped in their immobilized machine, could not understand how an enemy so tactically inferior in a one-on-one duel was suddenly attacking them from three different dimensions. Their bespoke weapon was designed for a linear battlefield that no longer existed. The combined arms network proved that the American forces could surround and destroy heavy tanks in isolated engagements. But the true test of a military philosophy is not how it performs in a single village. It is how it survives the devastating friction of an extended campaign. What happens when these two opposing systems, one built for the perfect duel, one built for the long march, collide in a sustained, multi-week offensive? December 1944. A narrow, snow-choked road winding through a dense pine forest. A massive German offensive was in its second week, pushing deep into American lines. The vanguard of a heavy panzer battalion had broken through the initial defenses exactly as doctrine dictated. But the lead heavy tank was no longer advancing. It sat completely silent in the freezing mud. The massive engine had stalled. A specialized fuel pump seal, hand-fitted in a factory hundreds of miles away, had ruptured under the continuous strain of the grinding, icy march. The vehicle was completely untouched by enemy fire. Its Krupp steel was pristine. Within 4 minutes, 3 American tanks were burning. The surviving vehicles laid down a wall of white phosphorus smoke and rapidly retreated. Its ammunition racks were full, but the tank was paralyzed. In the American system, this would have been a temporary delay. A standardized replacement part would have arrived via a light transport truck, and a forward mechanic would have bolted it in. But this was a German heavyweight. The pump was a bespoke component. The crew could not simply cannibalize a fitting from a nearby medium tank or a standard truck. Every machine was too unique. Worse, the division's dedicated maintenance company was 20 miles behind them, hopelessly trapped in a frozen traffic jam on a single, narrow road. The heavy recovery vehicles, the only machines capable of towing the 70-ton behemoth out of the forest, lacked the fuel to reach the front. The logistical umbilical cord had snapped. This was the quiet reality of a sustained campaign. The German High Command had drawn sweeping arrows on their maps, relying on the armor thickness and lethal range of their weapons. They believed these machines would force a strategic collapse of the American lines through sheer tactical dominance. But they had completely ignored the crushing friction of distance. As the offensive stretched into its second week, the heavy tanks did not die in glorious tactical duels against American armor. They died of mechanical starvation. A shattered track pin, a cracked transmission gasket, or simply an empty fuel tank became fatal wounds. Across the frozen landscape, the German army was hemorrhaging its most sophisticated assets without the Americans firing a single armor-piercing shell. Abandoning the crossroads entirely, the German commander popped his hatch and surveyed the field. His machine was mechanically pristine. The German commander in the silent tank checked his watch. The distant, rolling thunder of American artillery was steadily growing louder, signaling the inevitable counterattack. His machine was perfectly armed, heavily armored, and utterly useless. He had lost all meaningful options. He ordered his crew to dismount. They placed high-explosive demolition charges around the breech of their masterpiece main gun, pulled the fuses, and backed away. With a hollow, muffled detonation, they destroyed their own vehicle, turning a mechanical marvel into a blackened roadblock. Then, the crew began the long walk east, through the snow. The German system of bespoke engineering was fundamentally incapable of sustaining operational momentum. It was a brittle sword that shattered the moment. It was swung with full force. The true war of attrition was not being fought in the glass prisms of the gun sights. It was being fought in the supply lines, and the heavy tanks were defeating themselves. The German commanders were not blind to this reality. As the front collapsed, they occasionally captured American maintenance depots. They saw the standardized crates, the interchangeable parts, and the terrifying efficiency of the enemy's logistical machinery. The mechanical advantage of the American system was entirely visible, but seeing a mechanism and replicating it are two very different things. If the German leadership recognized that their artisanal heavyweights were bleeding their army dry, his crew was completely unhurt. They had expended only 5 rounds of ammunition to halt an entire enemy company. Why was their industrial machine fundamentally incapable of shifting to a strategy of volume and maintainability? Deep beneath the Harz Mountains, in a cavern lit by harsh electrical bulbs, the screech of metal lathes echoed against damp rock walls. This subterranean factory was the final refuge of German heavy industry. Above ground, the Allied strategic bombing campaign had systematically leveled the sprawling, centralized manufacturing hubs. To survive, the German military apparatus had to scatter its machinery into salt mines, railway tunnels, and camouflaged forest sheds. This physical reality was the first reason the German command could not simply copy the American method of mass production. Ruthless standardization requires massive, undisturbed factory floors. It requires a seamless, continuous flow of materials under bright lights, where 1,000 identical parts can be stamped and inspected in a single day. You cannot build a continuous assembly line when your transmission plant is hidden in a cave and your hull welders are operating in a barn 200 miles away. But the barrier was not just geographic, it was deeply cultural. The American tank program was driven by the unified automotive empire of Detroit, accustomed to producing millions of identical consumer vehicles. The German war machine relied on legacy arms manufacturers like Krupp, Henschel, and Porsche. Inside the steel hull of a Panzerkampfwagen Tiger Ausf B, a German gunner pressed his eye to his Zeiss optic. This was the absolute pinnacle of German military engineering, functioning exactly as its creators had envisioned. A heavy, highly sophisticated, heavily armored vehicle. These were proud, independent firms that treated tank design as an artisanal craft. They competed fiercely for state contracts, guarded their patents, and constantly altered their blueprints. A heavy tank completed in May often featured different suspension components and electrical wiring than the exact same model completed in July. To a German engineer, This was continuous improvement. To a mechanic in the field, it was an absolute nightmare. Even if the engineers had agreed to freeze their designs, the German state lacked the fundamental resources to fuel a war of volume. By late 1944, the naval blockades and bomber offensives had strangled the supply of raw materials. The factories were starved of tungsten, molybdenum, rubber, and crude oil. When a nation only possesses enough steel to build 100 tanks a month, it cannot afford to build expendable medium tanks. It is mathematically forced to make those 100 machines as thick, heavy, and lethal as possible, hoping each one can hold a vital crossroad indefinitely. The deepest flaw, however, lay in the hands that built the machines. The American assembly lines were manned by trained, well-fed civilian workers who understood the machinery. As the war dragged on, German factories were increasingly operated by forced laborers, prisoners of war, and concentration camp inmates. These men and women were starving, exhausted, and deliberately worked to death. An industrial system demanding bespoke, hand-fitted precision cannot survive on a workforce of enslaved people, had dictated the entire flow of combat. It had absorbed direct hits without sustaining a scratch and dismantled its targets. Quiet acts of sabotage, a slightly misaligned gear, a weakened weld, a loose wire became embedded in the heavy tanks long before they ever reached the front. The German military was trapped in a prison of its own design. They could see the American logistical machine dismantling their forces, but they were politically, industrially, and materially incapable of changing course. Their leadership remained obsessed with the idea of a technological silver bullet, demanding heavier armor and bigger guns as the front line rapidly collapsed toward Berlin. The factories could not adapt, which meant the soldiers had to pay the final price. The grand theories of armored warfare were no longer being tested on drafting tables. They were being violently resolved in the mud. What was the human reality on the ground when the final verdict between these two opposing systems was delivered? The German gunner who had executed the perfect ambush at the rural crossroads now stood in the freezing mud, miles from where the campaign had begun. His 70-ton Tiger was completely silent. It had not been pierced by an American shell. It had not been overwhelmed by aircraft. It was simply dead. A shattered final drive locked the massive steel tracks in place, and the specialized heavy recovery half-tracks had never arrived to save it. He watched as his commander ordered the crew to wire the pristine fighting compartment with high explosives. From a distance, the Americans simply could not bridge. Tactically, it was a flawless mathematical victory. When the hollow detonation gutted the interior, turning a mechanical masterpiece into a blackened roadblock, the crew turned and began the long walk back toward Germany. As they marched, the gunner looked over his shoulder. Rolling up the same muddy lane, vibrating the ground beneath his boots, was the American armored column. Some of the Shermans leading the formation bore the distinct, raw scars of recent combat. Freshly welded squares of standardized steel covered the exact spots where German armor-piercing shells had punched through days before. The American tanks were battered, stained with diesel, and tactically inferior in almost every measurable way. But they were moving. When the German gunner had looked through his Zeiss optic during that first ambush, he believed he was looking at the entirety of the enemy. He thought the war was a mathematical equation of armor, thickness, and muzzle velocity. He failed to see what was standing behind the American tanks. The question of armored supremacy in the Second World War was never really about which nation could build the most impenetrable fortress. It was about which system could survive the relentless, brutal friction of reality. The German High Command treated warfare as an artisanal craft, building bespoke mechanical giants that required a perfect environment to function. The American command treated warfare as an industrial process, building an interchangeable, resilient network designed specifically to absorb massive damage and keep operating. A 70-ton tank with the deadliest gun on the continent is not a weapon if it cannot cross a bridge. The crew believed that if they just repeated this performance at every vital intersection, the sheer, crushing weight of tactical casualties cannot be repaired in a forest and cannot be fueled. It is merely a steel monument waiting to be abandoned. The American forces won the continent not because their spear was sharper, but because the shaft behind it could not be broken. But a system is not magic. It is just a collection of human beings doing grueling, unglamorous labor. The true weight of the American armored victory was not carried by the generals who drew sweeping arrows on maps, or the industrial barons who owned the assembly lines. It was carried by the shadow army of the rear echelon. It was carried by the recovery crews who drove their unarmored tractors into active artillery zones to drag 30 tons of dead steel out of the mud. It was carried by the mechanics of the ordnance battalions, working under heavy canvas tarps in the freezing rain, replacing shattered engines with numb, bleeding hands. It was carried by the welders who spent their nights sealing up the violent holes where men had died, hosing out the fighting compartments and preparing the machines for the next morning. Long after the battle lines shifted eastward, the physical reality of the war remained in the quiet, muddy clearings behind the front, would eventually break the American capacity to wage war. But 48 hours later, the German commander looked through his binoculars. In the freezing dawn, an American mechanic, his uniform soaked in a thick layer of diesel fuel and transmission grease, wiped a heavy steel wrench with a dirty rag. He dropped the tool into a standardized canvas bag and slammed the wide steel doors of the Sherman's engine deck shut. The radial engine roared to life, shaking the cold air. The mechanic stepped back into the mud and watched the patched tank roll forward, heading back toward the sound of the guns, at the exact same approach route. The smoldering hulks of the destroyed Shermans had been pushed to the side of the road, and moving up the muddy lane, replacing the losses perfectly, was another American column. It was as if the devastating ambush had never even occurred. The American formation had absorbed the loss, processed the casualties, and simply resumed the offensive at full operational strength. The German crew had won the engagement effortlessly. Yet, as the distant rolling thunder of American artillery began to fall, around their isolated position, they faced a reality their superior optics could not explain. To understand why an army could consistently, the articulated glass was perfectly clear, gathering the dull afternoon light. At exactly 800 yards, the olive-drab silhouette of an American M4 Sherman filled the reticle. Lose these brutal head-to-head duels and still overwhelm the battlefield. We first have to look at the philosophy that built the German heavyweight and why its designers believed invulnerability was the only path to victory. The German obsession with the armored heavyweight was not born from arrogance alone. It was a calculated reaction to a mathematical problem. By the midpoint of the war, Germany was fighting a multi-front conflict against enemies with vastly superior industrial capacity and practically unlimited manpower. The German High Command knew they could never win a war of pure volume. If the opposing alliance could build 10 tanks for every one German tank, then the German machine had to be designed to destroy 10 enemies without being destroyed itself. This logic birthed a culture of uncompromising mechanical perfection. Inside the drafting rooms of firms like Henschel and Krupp, engineers were instructed to design land battleships. They moved away from the light, fast, easily produced vehicles that had driven the early mobile campaigns of the war. Instead, they focused entirely on survivability and lethal reach. The resulting machines were marvels of theoretical engineering. To support the massive weight of thick armor plates, designers implemented a complex system of overlapping and interleaved road wheels. The German crew had waited in the tree line for 3 hours. Their massive engine was turned off to save fuel. This intricate suspension gave the 70-ton vehicles a remarkably smooth ride, creating a highly stable platform that allowed the gunner to track targets easily over rough terrain. The armor itself was face-hardened and meticulously welded in complex interlocking joints. The optics were cut from the finest glass in Europe. The main gun was an absolute masterpiece, capable of sending a high-velocity shell through anything the Allies possessed from thousands of yards away. Every tank was treated like a bespoke, handcrafted weapon. In the factories, highly skilled machinists hand-fitted individual parts. If a gear in the transmission did not mesh perfectly on the assembly line, a worker would file it down by hand until it operated smoothly. It was an artisan approach to industrial warfare. The military leadership looked at these towering steel fortresses and saw the ultimate tactical solution. They believed a weapon so heavily armored could lock down an entire sector of the front just by its presence. To the crew sitting inside the steel hull, this philosophy felt entirely justified. They felt safe behind thick steel. They had the power to reach out and destroy the enemy long before the enemy could pose a threat. The calculus of the heavy tank seemed proven by the incredibly lopsided kill ratios achieved in individual skirmishes, exactly like the ambush at the rural crossroads, the 70-ton tank sitting silently in the shadows. They had simply listened to the grinding, unmistakable approach of an American armored column. But a tank is not a static concrete bunker. It is a machine that exists in a harsh physical world, constantly subjected to gravity, mud, weather, and the brutal laws of physics. The very features that made the German heavy tank a masterpiece of lethality also made it a mechanical time bomb. The overlapping road wheels that provided such a smooth ride were a trap in freezing weather. Deep mud would pack tightly between the closely spaced wheels during the day and then freeze solid overnight, locking the tracks completely and paralyzing the vehicle by dawn. The bespoke, hand-filed gears meant that a factory-fresh replacement part might not perfectly fit a broken transmission in the field without hours of careful modification by a master mechanic. The German command had built a weapon designed to win the perfect tactical duel, but they had fundamentally misunderstood the nature of the long campaign. The true test of armor was not just how well it could kill, but how well it could sustain its own weight over hundreds of miles. While the heavy tanks dominated the brief moments of combat, they were quietly losing a much larger battle against their own complexity. What invisible cost did this obsession with mechanical perfection carry into the field? The crew was calm. They knew exactly what was about to happen by every rule of armored warfare they had been taught. The true cost of the German heavy tank was rarely paid under enemy fire. It was paid on the road. Moving a 70-ton machine across a devastated European landscape required fighting a relentless, exhausting war against gravity and geography. When a heavy armor battalion received orders to reposition, the friction of the march began instantly. A standard stone bridge that easily supported infantry and transport trucks would fracture and collapse under the sheer mass of a tiger. Routes had to be meticulously scouted. Detours had to be mapped through soft fields and deep mud, forcing the massive Maybach engines to run at maximum power just to keep the wide steel tracks turning. This created an immediate, crippling demand for fuel. The heavy tanks did not measure consumption in miles per gallon, but in gallons per mile. Every operational combat vehicle required a dedicated umbilical cord of soft-skinned supply trucks trailing behind it. If Allied fighter bombers destroyed those trucks, or if the deep winter mud simply swallowed them, the invincible steel fortress became a static pillbox. A tank that cannot move is no longer a tank. But even with ample fuel, the physical strain of dragging 70 tons of Krupp steel, this was not going to be a battle. It was an execution. The gunner depressed the firing pedal, tore the machines apart from the inside. The final drive, the mechanical gearbox that transferred engine power to the tracks, operated under constant, unnatural torque. When a driver tried to pivot the massive vehicle in thick mud, the internal stress often exceeded the limits of the metal. With a violent, grinding snap, the gear teeth would shear. The deafening sound of cracking steel would echo inside the hull, immediately followed by the acrid smell of burnt transmission fluid. The tank would slew to a sudden, permanent halt. The crew, entirely untouched by enemy fire, was suddenly out of the war. In an American unit, a broken transmission was a severe operational setback. In a German heavy battalion, it was often a fatal blow to the vehicle itself. The artisan engineering that made the tank so lethal made it a nightmare to repair under combat conditions. To replace a shattered transmission, the entire turret, weighing roughly 15 tons, often had to be carefully lifted off the hull to access the internal machinery. This procedure required specialized heavy gantry cranes. If the tank had broken down on a narrow, soft forest trail, under freezing rain and the threat of enemy artillery, those cranes simply could not reach it. The 88mm gun fired with a concussive shock that forced the air out of the fighting compartment and shook dust from the turret roof. Even towing the paralyzed machine out of the danger zone was a monumental operation. Dragging a dead weight through the mud often required 3 heavy recovery half-tracks chained together in a line. If those specific recovery vehicles were busy elsewhere, or if the front line was rapidly collapsing, the crew was out of options. They would rip the optics and radio equipment from the hull, wire the pristine fighting compartment with demolition charges, pull the fuses, and begin the long walk back to friendly lines. This was the invisible attrition of the German armored force, without the opposing army firing a single shot. Entire companies of heavy tanks would melt away during a retreat or a long approach march. The German military was winning the isolated tactical duels, but bleeding its irreplaceable machines into the mud. The German system was brittle, failing under its own magnificent weight. Yet, across the same freezing fields, the American forces were moving constantly. They were taking heavy casualties in direct combat, losing tanks to the superior German guns. But their formations never seemed to shrink. While the German machines were breaking down and being left behind, what kind of machine was rolling up the road to replace the burning American tanks? The armor-piercing shell crossed the damp field in less than a second. It struck the lead Sherman dead center, piercing the transmission housing. The answer was not forged on a European battlefield. It was shaped by a massive, unavoidable geographic barrier, the Atlantic Ocean. In the sprawling shipyards of the American East Coast, the cold salt air mixed with the sharp scent of cosmoline and heavy grease. Massive dockside cranes hoisted 30-ton blocks of olive-drab steel high into the air, lowering them carefully through the narrow hatches of waiting Liberty ships. This was the absolute physical constraint that dictated American tank design. The United States certainly possessed the industrial machinery and engineering talent to draft a heavy, thick armored behemoth to rival the German giants. But a 70-ton fortress was strategically useless to the Allies. A vehicle of that size would snap the cables of standard port cranes. It would consume too much critical tonnage on a cargo ship, and once it finally reached Europe, its sheer mass would crush the temporary Bailey bridges that combat engineers relied upon to keep an army moving across blown rivers. The American solution was a conscious, calculated, industrial compromise, the M4 Sherman. At roughly 30 tons, the standard Sherman was less than half the weight of the German heavy tanks. Its steel armor was noticeably thinner. Its standard 75mm gun lacked the crushing, long-range kinetic energy of its adversaries. The planners in Washington and the commanders in the field knew exactly what they were building. They knew that in a direct, head-to-head engagement,